Hi, I'm Emin, and this is my video presentation for my Physics 101 lab project. The topic of my project was the effect of dampening in harmonic motion. Before the experiment, I first constructed a simple pendulum using a glass ball and string, and tested it to make sure it did not have any undesired spin or instability. Before the experiment, I measured the mass of the pendulum and the length of the spring. The experiment had two phases where I would test the pendulum in two different mediums, air and water. During the first part, I timed and recorded the motion of the pendulum in air starting from 5, 10, and 15 degrees respectively, as the theoretical frame we use to analyze harmonic motion makes a small angular approximation. I expected the values to differ as the angles got larger, and my final analysis of my data showed that this was in fact true. During the experiment, I observed that the pendulum took quite a long time to come to a stop. From this, I concluded that the coefficient of air friction must be quite small. Our final results will show that it was in the range of 10 to the power of -3. Then I used an alternate analysis where I used a different formula to obtain the value of the coefficient of air friction. In order to use this formula, I first had to measure the period of the pendulum. I did this by analyzing my recording frame by frame. I then repeated the experiment in water. This time, the pendulum came to an abrupt stop. This result would imply that the dampening constant of water is significantly higher than that of the air. After doing the necessary calculations, we found that it was nearly 90 times that value. This will corroborate a result of how quickly the pendulum came to a stop in these two different mediums. We then repeated the frame analysis, this time in water, to compare the results we get through the two different formulas. Overall, we concluded that the theoretical model used to describe damped harmonic motion was reliably accurate to real-life experiments. We found that the impact of air friction was very negligible, which was justified ignoring this effect, especially in situations where other forces are dominant. The impact of the dampening of water, however, was significantly stronger, and would have to be taken into account during calculations.